Hello, today I am going to discuss how I was able to do a single sample t-test. And really, just with all of these tests is what I've learned that numbers can be deceiving. So the best thing to do is to analyze and break down and use all the tools that we have available to us to learn if the data is worthy data, is it correct data, or is there issues with it. So to start, for this is just, first you have to decide on what your question is. So you've got to start with the end in mind. That way you are able to narrow down your data to pinpoint exactly what it is that you need, because there's a lot of other data that sometimes you don't need. So for my question to start off was simply about, excuse me, is the raw score mean for the African American population on the 2018-2019 STAR tests significantly different than that of the African American population in one district? So first, what I did is, of course, I had to go to TEA to get the information for African American, as you'll see right here. And once again, you find that on TEA, and that is the main p-value charts. And then of course you're looking for exactly depending on what you're looking for. So I was looking for African American, and then I'm looking for reading, and then right here is the mean and the standard deviation. So once you find that, it is time to find the actual mean and deviation of your data. Mean is the average, so simply you can do equals the average, and then I just simply highlight all of the raw scores, and my average was 23.2. For the standard deviation, it's also a formula. Once again, equals standard deviation. Make sure you select the S. And once again, you select those raw scores as well. So by just glancing at it, it looks like, if you're really looking 21 to 23, this is almost 21 as an average compared to 23. 2 points is quite a bit of difference when you're looking at a STAR score when it only goes up to 30-ish anyways. So, but just by looking the standard deviations, though, they're not even 1 full point off. So it does take some analyzing and comparing to see if it's significantly different or is it really the same. Because when you just glance, the mean looks different, but the standard deviations are closely aligned. So of course we chose the single sample t-test to determine that. So just following the steps, of course, next you're going to pick your test. And of course, we did the single sample because we want to compare if the population is different. But of course, we're just pretending because we do not have the population standard deviation, but we do based on what was given to us by TEA and then what formulas I use to figure out other data. Once you decide on your test, before you can move forward, you do need to check for all your assumptions. And just simply this is putting just making sure, kind of putting your ducks in a row before you do your test, and then it's really not valid because you didn't check for assumptions. So when it's talking about random, it's just truly random. Of course, if you were to go select your top students, that would not give you valid results because of course your scores would be skewed. So doing it random anytime, I think that's true for any kind of test. If you really want to have valid data and feedback to make a plan, then it needs to be random. Also, it's independent of observation. So what one student did at one campus in the district doesn't depend on what the others did. They're all singled out by themselves. So it doesn't matter what one campus did to the other, vice versa. They're all independent of one another. And then to check that the dependent variable is normally distributed, I did do the histogram and box plot. Now, just a reminder on how to do this, and this is kind of where I had stopped originally because when I'm looking at it, my data looks a little skewed, and I did look for outliers. So, and the reason I went to look for outliers is because, once again, if I was to draw kind of a, if you will, I guess more of the curve, it would look something like this. I'd start over here, then go up, then down, then up again. So I would have the two humps, and I was thinking, I'm just not sure if that's correct or if I messed up along the way, but partly because I chose African Americans. As you can see, I actually only had 30 numbers kind of we're dealing with, which could make a bigger difference. So that I feel like may have been part of that. But after talking, we decided to go ahead and go on. But just a reminder on the histograms, of course, you make your bend table. And I went all the way up to 33 because that's the height. My scores went up to, I think, 32. So I stopped at 33 to include all. And then, of course, the frequency is just showing who made what. And when I look at the score, I can see like I had a 10 and I had 13. Well, if you're thinking about a STAAR test and the average is 20 to 24, well, 10 and 13 are pretty low numbers, which throws this out. And so that is why the graph looks like that, because I did have several that made 13 and 10 in these lower numbers, causing that to rise on the graph. And then you can tell as we got to the higher numbers, 29, we're at 7. So that would be the most, right? That would be the mode. That's who had the most, was up here creating the second heel you see. So that is where I stopped originally, because I was getting kind of, it kind of questioned me as whether or not this would be a normal or not, normal frequency or not, due to it having 2. So from my understanding, it probably would not be as normal because you would want it only to have one big hump. But either way, these are the scores, and this is what I chose to use and continue with. And then, of course, the box plot, it just helps kind of break it down a little bit more where you can see where the outliers are. Because you're really, if you look right here, you're really wanting a quarter here and a quarter here, but we can easily tell that there was more on the lower half than the top. But it's still, you know, it's still pretty close to proportional, but you can tell that there's a bigger area that scored lower. But once again, only having 30 can also make a big difference in your data, because we know the more numbers you have in the data, it will not look the same, because you're dealing with more numbers. So that was just something to keep in mind. So after we decide that it looks normally distributed, but once again, I would question this first, and that's why I stopped originally, but I'm going to continue on for this one, and then maybe, Dr. Cooper, you can correct me if I'm wrong. So, but anyway, so that kind of is where that could stop you if you're not, because you're looking for it to be normally distributed. Then we move into the hypothesis, and really what we're just saying here is that the null hypothesis is simply the population, the mean of the African Americans for the entire population is the same as my sample population. So for the null hypothesis, I'm saying that they're the same. There really wasn't a big difference. Now for the opposite, the alternative hypothesis located right here, the second one is saying that these populations are not the same. So they are not the same. So we are having to decide, but these are the hypotheses to start with, and then we're going to decide which one of those, after we run the data and the test, what actually is going to be the correct answer. Of course, setting the alpha, we talk about in education, it's always 0.05. We have that percentage leadway a little bit because we're dealing with education and not necessarily someone's lives are on the line. So we have a little bit more leadway. Of course, you would want a smaller if you were dealing with lives or something more pertinent, I would believe. So before we can get into the t-test, we got to have a little bit of data. So calculating the statistics, we need a few numbers. The n is just simply how many students were there, really, in this case, how many students. So there was 31 here, but you got to remember the top line is actually your column headings. So you take that, so there was 30. And then I have a degrees of variance of 29 because you always subtract 1 just to have a little bit of variance. Now, this TCV number is the critical number, and I found it right here, and I'm not too sure what happened with this little box, but it looked like this originally. And what this is telling me is 0.05 was my alpha, what I chose, because I'm trying to figure out how I got the T critical number. So I want to show you this table, of course, is in our books, but you can also find these online if you're looking for a particular t-test. You can Google these charts as well. So it's nothing to remember, but you do have to have it because it's based on your degrees of variance. So 0.05, and we did a two-tailed test, meaning on each end it does have a tail. And then for mine, it was only 29. So you just simply look down, 29, and then 0.05. So this is the column we would be. And here would be 2.045. So that is where I get this critical number. Now, this actually will run for you under the data tool packet, but you do need these numbers to help get you started That way it will make it for you. So once again, I use the chart here to get the t-critical number to be able to run the sample t-test and get the data for that. Now it says 2 sample for means, but we know that with the data tool pack, and I can show you the data analysis, we do not have an option for just that single test, and that's what we're doing. So we had to pretend, so we're using 2 samples. But before I do show you that, I did add the dummy data, and I had to put zeros, and you have to put zeros, so you have to make it equal however many kind of variables, in this case with students, I have. So I had 30, so I had to put 0 all the way down to be able to run that data. And you'll want to do that before you run your t-test. So once you add that, you are just simply truly going to data analysis, and then we are going to choose the t-test, and it's the first one. It is the pair 2 sample, but once again, we know we're only testing 1, but in this case, we don't have an option, so we're going to choose that. The variables and output were just simply exactly that. It already has your alpha for you. And your hypothesized mean, that is what you're going to get from the top when you had your mean up there for your population group and the total population. You can choose one. It doesn't really vary much. But your variable is simply those raw scores. So this first column is just simply my raw score right here. And variable 2 was all the zeros because I'm really just wanting to run one set of data. So variable 2 is all my zeros. The mean is simply from the very top. If you include labels, click labels. And then my output, I actually selected to go right here, so I was able to look at it and see what was going on. So this just kind of puts it all together and gives me a little bit of data to see how critical it was with this t-test. Is this going to accept the null, or is it going to fail to reject the null, or is it rejecting the null? So basically, are these tests very close, or were they not? Because remember, I'm trying to answer this question: is the mean significantly different or not? So based on my data, I can already tell you that fail to reject, so I can say the means are very closely aligned. They are not significantly different. The reason I'm able to tell you that is this 2 tail right here. So this tells me both of my tails. Once again, here's a tail and here's a tail. And it's 2.05 if we round it. So I just simply put a little bit past negative 2.05 and then positive 2.05. And my t statistic, which is the very important one because that tells me where it falls inside or outside the category, as you'll see on the second spread we did. That, is it aligned or is it not aligned? Are those means significantly different or not? So in this case, you'll see by where the 1.82 falls, it is in between these two. So it's failed to reject the null and simply saying that these means are not significantly different. However, if it would have been a pass either on the front tail or the back tail, then we would reject the null and it wouldn't. So as we interpret the results, the graph just helps you understand and see it visually a little better, but all it is this data right here. So there was 30 observations, my degree of variance. There's my hypothesized mean. Here's the actual mean when we put that data together. So it just kind of puts it visually for you so we can see what's happening. So as you can see here, and these are just my results, and this is where it said, of course, the fail to reject the null is if those were equal, and then the alternative hypothesis where we're going to reject it means they were not equal. Okay, so that's the 1 and 2, which is really the same as my hypothesis of what I started with. So, but this actually is going to show you what my answer came to be. Because of my t statistic being 1.82, it is a less than, so it's less than 2.05, because here it is, it's less than that. That tells me that value, we're going to fail to reject the null, which I just said a few minutes ago. We're going to fail to reject the null because it is inside this variance right here, this degree right here, this difference. Since it's in between these two lines, that tells me I'm in the middle and it has failed to reject the null. And this is just saying that really in a number values statement. This just talks about there was 29 equaling 1.82. Okay, and it's greater than 0.05. So the average raw scores in the 2019 STAR test for African Americans for this district, 23.2 were the same for the fourth grade reading star scores for the African American population of 20.95. So once again, that just tells me just by glancing at numbers, they can be deceiving, because if I was to just take a guess, I'd be like, oh yeah, those were different. When really in reality, they were not different based on what my data shows me. So that is just something to truly remember when we are thinking about numbers. Are they really what appear what they are? And we don't know that without doing more analyzation and really using the tools that we're given to do that. So once I find this, now the other tests are not necessarily something I would have to do because I didn't reject it. However, we're just trying to prove our points here, really. For the rest, from my understanding, it's not something you have to do because we did not reject the null. We actually failed to reject it. However, these just kind of break it down a little bit, and you're able to check your numbers really and see, did they really line up where they should have lined up? So it's really just checking your work. It is a lot of formulas, as you'll see in the side, because we'll start with the effect size and Co&D. And it's really just a lot of different formulas, and you just have to really follow what they say to give you the examples to figure out the numbers to be able to run the different types of formulas. So just kind of starting off, not too sure why this moved over. Effect size, like I said, since it was a small difference, and where I got that was right here, because 0.2, okay, because here was my numbers. So I was just trying to see exactly what would my co-NDs be based on that. Is it a big effect or not? But so this is how I figured this out. And it says, since there was no difference, it failed to be rejected. Effect size would not be calculated because there was no effect. However, to be sure there was no effect, we did calculate it just to kind of show. So the sample mean and hypothesized mean are from the very top. Here's my numbers, and here was also the standard deviation. You can use them from there. There are also other places. So really for this one, I'm just trying to figure out this. What was it? And the 0.33, and that's how I end up knowing that it was a small effect actually based on my Cohen's D. But like I said, since I failed to reject it, this is something that necessarily we wouldn't have to do. It is just trying to validate our original results. But once again, you get all of these information is from the top. You already have that. You're really just putting it in this formula. And as you'll see right here is where I actually did that. Where you subtract it, then you're going to divide by the standard deviation to get that effect size. And as you see, there was, and as I went to the effect size on down, I did state that it was a small because it actually was 0.33. And as you can see, that is a small effect. So you would want to be careful, especially when analyzing data, to see if you're talking about programs and such, or what kind of effect is it having. And even more research would have to be done depending on where it falls. But since there was a small difference and it failed to be rejected, effect size will not be calculated because there was a small effect, however, to demonstrate. So once again, just another, we have Cohen's D effect size. This is another way to do those sizes, except it's just a different formula. So of course, this is just another outcome variable to test it out. These numbers are also listed on top. Your T critical is going to be, or yes, your T statistic, excuse me, is right here. You already have that number. That's the first number. This is just saying take this number and square it. So we know square is just multiplying by itself. This is degrees of that variance. Remember, I had 30 sets, but we're going to subtract 1 to have the variable. So it's 29. And then once you simply put it inside this formula, you're going to get a number like this. So here's just my formula again with those numbers. And here is what my answer was. Now, you have to have these numbers because you're really just verifying the original data, honestly, up here. What you're verifying your t-tests, your pair, which is not a paired in this case, it's a single test, but you're really just wanting to look, is this correct? And so this is just another way to double check yourself. And the last one just simply goes with your confidence interval. And I like to think about this about, really, is it confident? Are you confident with your answer based on, so I said earlier that we failed to reject. We're right here in the middle. And by doing all the other steps and getting to the confidence, you really realize were you right or were you wrong? Was your especially with this being brand new information to us, and especially me, you really learn, okay, did I ever do it right or did I do it wrong? So the confidence interval, once again, is a very big formula, but you're given most of these numbers already several places. So you're really just trying to, figure out your answers. That way you can put them in the calculations. Now, you'll see these are two of the same thing because you got to do one with a plus and one with a minus. So my information is the same. These are just your plus and minus because remember, we really have two tells, so you're going to have your two sides. So when you're doing your confidence interval and using the formula, that is what you have to do. So as you can see with my results though, 4.94 would be somewhere down here, and the negative 0.44 we know is not quite to 1 would be right here. But I know that my t-statistic was 1.82, so this is how I know that I was on the right path or did it correctly. It's because if I go ahead and graph these two on the chart, which you don't necessarily have to use a chart, but it does help just visually, once again, just to see what you're saying. Then I know that 1.82 is in between these two numbers once again, verifying that sure enough, the answer to my question, they are not significantly different. I am going to fail to reject the null. So simply meaning these two tests, those means on those are not significantly different, even though, once again, numbers can be deceiving. So it was, especially for the first time, a lot of information just going through it and understanding. This is just showing that range. Understanding really what it is, and then just how to find out some of these numbers. You got to do a little bit of calculations, which Excel is really good about doing them all. You just have to make sure your parentheses and such are in the right place. So I just double checked them with my computer calculator, which works like a TI-83, to make sure I had the true, the correct number. So, but I learned a lot. I do understand the value in this. I just don't feel like maybe we do this enough. We don't verify or analyze our data enough. We just simply say, oh yeah, that's significantly looking different numbers. I can see 2, but that's pretty big when you're getting into testing and STAR, like I said before, and we simply would stop right there. So I like this, but I will say it just took me a little bit to understand it, but as I did it multiple times, moving through the different modules after this one, I began to really understand what we are doing and why. So I look forward to the other modules because, like I said, I'm feeling more comfortable. It's just really having all these tables and charts readily available because you need all of them. You need all the formulas. So just understanding where to find some of these graphs was helpful in the long run as well. So, but I look forward to the next module and sharing that so I can be able to analyze data when it is my turn as principal. Thank you.